Alright, here we are again in Just Maths Algebra Chapter 4, and this is our 15th lesson named Useful Results. I would like to give a shout out to A.J. Hobson for the outline of this series. So, have you ever looked at a number and wondered, how did we get here? Like, what if I told you that a very big number, every exponential blast, has a secret code behind it, and that code is a logarithm. So today we will unlock the mystery of logarithms. We're going to explore some powerful rules and yourself. Okay, so let's get started on this lesson. Alright, so let's start simple. So a quick review of our last lesson. So if b is a fixed positive number and x is another positive number, such as x is equal to b raised to y, we say that y is logarithm to base b of x, and we write y is equal to log b of x. So imagine this equation that x equals b raised to y. So b is what you call your base, and it is a fixed number, and x is your result. So the question is, like, what exponent of y do you raise b in order to get x? You're looking for exponents. So if you're like looking for exponents, let's say x is equal to b and the exponent is y, and like you're looking for y, like x and b is x and b is given. So like if you're gonna swap, you're gonna reverse the situation, and you're gonna look for the exponent, you will come to the logarithm of x base b, or log b of x, right? So that's how you will get the y. So here's the definition. So y is equal to log base b of x means that y is the power you put on b to get x. So to further understand this, let's have an additional review that I didn't cover on the last topic. So, example, we have 3 squared is equal to 9. Let's say 2 is not given. Like, what exponent will you give 3 to make it 9? Now, if you're gonna look for that, so you're gonna get log base 3 of 9 is equal to 2. So you're gonna ask this question, like, what exponent should I put 3 to make it 9? So the answer is 2, because 3 raised to 2, or 3 squared, gives you 9. So logarithms are exponents. Like, they tell us many times to multiply a base to get to a number, right? So useful results. This is our main topic. Oh, by the way, I have more additional things to do and to give. So on this one, that is what you call the exponential form, and this is what we call the logarithmic form. So they are what we call the inverse functions. Like it's like pressing undo and redo on a computer. They reverse each other. Okay, let's go back. So here's this result. This is very useful, especially when you're working on logarithms. So for any positive number x, b raised to log b of x is equal to x. So any positive number that can be expressed as the power of b without necessarily using a calculator. What? Any positive number can be expressed as the power of b without necessarily using a calculator. We have simply replaced the y in the statement of x is equal to b raised to y by log base b of x in the equivalent statement y equals log base b of x. So like this tells us that if you raise base b to the log base b of x, you will get x itself. So like it's saying like I'm undoing the logarithm by using the base. So it shows the connection or that the exponential and logarithmic functions cancel each other out. So like if we go have here, because it's simply like canceling that. That's and it will give you x because both of the base and the base of the exponents are the same. Next. So for any positive number x log base b raised to y is equal to y. Any number can be expressed in the form of a logarithm without necessarily using a calculator. We have simply replaced x in the statement y log base b of x by b raised to y. In the equivalent statement x raised to y. So, this tells us that the log of b raised to some power y is just y. Again, these functions just uh, cancels out also because they are inverses. Like the base of the log is b and the base of the exponent is b. So like they simply cancel and it will only give you the exponent. So these identities are powerful and useful because they simplify complex looking expressions. Like you're gonna tell yourself, what does this even do? What does logarithm even do in real life? Why do we care about logarithms? So let me show you a real we places you will find logarithms. So like it it is the decibels in sounds, like the volume you hear. So it's measured on a logarithmic scale. Without logarithms, you don't have any volume on your phones, like because yeah, it goes deeper than that. It also uses like the Richter scale for earthquakes. Each number on the scale represents 10 times the increase in magnitude. We won't be able to know what the magnitude of an earthquake if we don't have these logarithms. If we're gonna take computer science, the binary system, it works on log base 2, which is more efficient. So yeah, so they're just arithmetic exercises, like they're behind how we measure, search, and survive. So yeah. So a few tips for you to avoid mistakes. Um, so don't confuse the base and the result, because in log base b of x is equal to B is the base and X is the result. Okay, so don't forget also that logarithms only work in positive numbers. They don't work on negative numbers. They don't work on imaginary numbers, only positive numbers. Always check your answer, and always check if you can simplify. You can simplify the equation. Like, start asking like, what exponent do I really need? Okay, so let me give you something bigger than math. So, like in a logarithmic function, what it seems like a huge number, you will think, you will get overwhelmed by that, but it becomes manageable and so on and so forth. So when we ask the right question, what power this result, what exponent do I need to get this result? So life is the same. When we face challenges, you know, it's easy to get overwhelmed, right? Because of the size of the problem. But when we break those things down step by step, layer by layer, we will eventually find the root, the power within us that created us that result. So, every big outcome starts from a small, consistent power. Your choices, your beliefs, your efforts, understanding the roots of what you build, and you'll never fear the result. Okay, so thank you so much for being with me this lesson. So I'll see you in the next one, and thanks for your attention.